number of common factors. So for this problem, we are giving two numbers, for example, a and b. So we're going to return the number of common factors of a and b. So for a equal to 12, b equal to 6. So they have the common factors of 1, 2, 3, and 6. So we're going to return a 4. How can we solve it easily? So for numbers a and b, so if b is a factor of a, so what's going to happen? If b is a factor of a, so we just need to check how many factors of b. So for b, it has 4 factors, so we're going to return 4 directly. Yeah, but what if a is what if b is not a factor of a? So for example, a equal to 7 and b equal to 6. So the common factors are going to be 1. Because for 7 it has 1 and 7, and for 6 it has 1, 2, 3, and 6. Yeah, it only has 1. But how can we solve this problem easily? We can directly use the property of greatest common divisor, GCD. So we're going to use the GCD of the two numbers. So for example, 12 and 6. So it's going to be 6. Because the 6 is going to be the greatest common divisor. We find the greatest common divisor, and then we can directly use this 6 to check how many divisors. Because for 6, it has divisors 1, 2, 3, and 6. Definitely it is a divisor of 6, and it is a divisor of 12. Maybe we're going to use another example, 6 and 9. So the GCD of 6 and 9 is going to be 3. So for 3, what is the common divisors? It's going to be 1, 3. 1, 3 is the divisor of 6, and 1, 3 is also the divisors of 9. So it means our result is going to be 1, 3. Now let's just use this idea to solve the problem. Yeah. First of all, we're going to check this number n. It's going to be GCD of a and b. And then we just need to check how many common divisors. So the first method is going to be just a for loop. So for I in range from 1 to integer of square root of n plus 1. So if n modulo I equal to 0, so we're going to count it. But we need to check if I equal to n divided by I. So this means it is equal. The two numbers are equal, but we need to find the unique numbers. So the result is going to pass equal to 1. Otherwise, if they are not equal, because for this I and n divided by I, it's going to be just those two numbers. So for example, if it is 6, it's going to be 2 and 3. If it is 25, for example, it's going to be 5 and 5. But we need to count 2 times. We just need to count 1 time. So this is the 5 and 5 case. Yeah. Otherwise, we are going to plus equal to 2. And finally, we're going to return the result. Now let me just run it and submit it. Yeah, as you can see, it works and it's pretty fast. And this is a square root of n time complexity. So currently this n is just 1000. But what if this n going to be a really big number? Because definitely this is a square root of n time complexity. So for I in all those possible cases. And for this one, this is a log n time for a and b. So the time complexity is going to be the maximum of log n and square root of n. It's going to be the maximum of those two. Yeah, of those two numbers. But what about we just use another case, another method? It's going to be really easy. So we're going to try to find all the factors. We're going to use construct method to solve the problem. So we're going to construct all the factors, and we're going to put it inside a dictionary. I'm going to call it factors. So for here, I'm going to calculate the divisors. So with the number n, yeah, it's going to be a just for loop for j in range I to n plus 1 to I, and the factors j gonna append I. Finally, we just need to call the divisors function. And for this one, we're going to use 1000, because 1000 is going to be the maximum number, because a and b going to be 1000, and GCD of a and b must be less than 1000, right? Now, we've already prepared everything. What are we going to return? We just need to return our final result. so it's going to be the length of factors with this number because everything we already calculated. We just need to check the length. Yeah, now let me just run it and submit it to check. As you can see, it works and it's pretty fast. So the idea is for this example, for this number 6, n equal to 6 for the first example, and the factors of 6 we've already calculated. Actually inside it's going to be 1, 2, 3, and 6. So we just need to check the length of the array, which is going to be 4. Yeah, this is the idea. I think that's all about it. Thanks for watching. See you next time.